Welcome back to our live training session. We're going to be taking a look at how to complete the base map creation process in this tutorial. So we're going to be setting up our two-dimensional and three-dimensional tables so we have good values in there for the engine to fire up and run and have appropriate fueling and spark timing and variable cam control. Let's jump in and take a look at some of the areas that we haven't touched on in that last tutorial. The very first thing we're going to do is move over here into the MTune software under navigation pane. We're going to go from the top to the bottom and make sure we didn't overlook anything in that last process of setting up our inputs and outputs and some of the background details. So under configuration here, everything in here should be covered. Now under the limits, so we haven't touched anything with our rev limiter or boost cut or lean cut. Let's talk about our rev limiter. Here we have our RPM source and we can have a couple different options here. I'm going to have it just a single value, and then the rev limiter here, because the engine has upgraded valve train, we have upgraded pistons and rods, the engine can rev fairly high. It also has an upgraded Type S oil pump. I'm going to set the rev limiter at 9,000 RPM. I don't plan on going that high, but we'll set it at 9,000 just so we don't hit it on the dyno. So set it to the maximum RPM you anticipate revving the engine to. So if I was planning on going no higher than 85, set it at 85. I'm setting it at 9,000 again, just so I can rev it to 85 in the dyno and not touch the limiter. Okay, so the rev limit type, we have some options here. Fuel, spark, fuel and ignition, so fuel with ignition 100 RPMs later, or ignition and then fuel 100 RPMs later. I'm going to choose ignition with fuel 100 RPMs later. Now the dual mode rev limiter we're going to keep off. The cut pattern, I'm going to put it to sequential RPM control range. This is going to say here that 200 RPMs before the 9,000 RPM max limiter, I'll start the percentage cut, and 0% is going to be at 8,800. So at 8,900, I'd be at a 50% cut, and at 9,000, I'd be at a 100% cut. So this will have more a progressive style limiter. It won't be as abrupt, and definitely a little bit smoother. So 200 RPM control range is fine there. Rev limit ignition retard. So this is how much timing I'm going to pull out on the spark timing, or retard the spark timing when I'm on limiter. In this case, I'll say 10 degrees. So 10 degrees retarded. Now we have to put a value here, negative, not positive, so negative 10. Fuel enrichment, I'll go ahead and enrich my limiter up maybe 5% when it's on limiter. There's a predictive limiter, which we're going to leave off. The predictive limiter is going to be for something that the engine that revs extremely fast, and whatever reason, the normal rev limiter may not catch it. So this would be motorcycle, for example, motorcycle engine, the bike engines that rev very quick. I'm going to leave that disabled. Boost cut, we do not want on. We're naturally aspirated, so that does need to be on. EGT power cut, we're going to disable that. Warnings, so max RPM warning level, I'll set that to 9,000, not 900, 9,000. Map warning, anything over 120 kPa I'll allow it to warn me, because in that case, some reason I'm building positive manifold pressure and I shouldn't be with a naturally aspirated engine. Coolant temp warning, anything over 220 is going to be concerning here, so I'll put it at 220. Lambda deviation warning, so anything more than 0.1 above the desired lambda for my target, it can warn me. Injector duty cycle warning 90, EGT warning doesn't apply. High voltage warning, I'm going to say anything above 16 volts concerning here, so we definitely want to check that out. Okay, so we've set our warnings up here. There's advanced warnings. If we go here and just take a look at this, this would be for some additional programming. The output mode, for example, would be to flash the check engine light. I don't have the check engine light configured here, so I'm going to leave that off. Oil pressure cut, disabled. We don't have an oil pressure sensor. And general purpose limiters, they should all be disabled. User cut table should all be disabled. That's going to lead to our lean power cut. Now, on a naturally aspirated engine, I'm not super worried about having a lean cut. However, I can configure it just the same. So the minimum map, in this case, I'll say 90 kPa, minimum RPM, 4,000 RPM, and then minimum throttle, 80%. The threshold source, lambda threshold, fixed value, anything leaner than 95 lambda, that's going to be a concern here. Soft cut misfire, that's going to start to create a misfiring event, so it warns me there's a problem. Time before total power cut, 0.8 seconds. Reactivation, I have to be below, in this case, let's say 40% throttle for that to turn off, to get us out of that condition. So this should be fine just for a basic lean protection failsafe. Again, I'm not super worried about on a naturally aspirated engine. On a forced induction engine, I absolutely would have a lean protection, because things can go wrong really quickly if it gets lean. Naturally aspirated, not so much. Okay, so now that we've checked over our limits here, let's go to fuel Fuel general we did set up. This is all.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.